Welcome to Atega Tech Academy. Today we'll be looking at Thevenin's assessment. So we'll take a question. It's really in our reference book, and if you see the question, if you don't take time, you might not know that it's a Thevenin's question, but it's a Thevenin question. So I'm just going to take us through the solution in just maybe in the next 3 minutes. So please remember to like, share, and subscribe. Okay. So our question says, what would be the reading of a voltmeter when connected across the terminals AB. So, in our first diagram that we have in our left hand side, this diagram, they're saying what will be the ohm meter reading. We know that what is measured in ohms, uh, volt, what is measured in volts, voltage is measured in volt, and the device that is used to measure voltage is called a voltmeter. So they said when we connect a voltmeter to this circuit, what will be the readings? I'll do a simulations to really also confirm these answers we will get. So if we connect a voltage here, that means a voltmeter, that means they are just telling us that we should find VTH, Thevenin's resistance. And to find VTH, let's say this 12 volt will deliver a current. Let's name that current I1. But when I1 gets here, it will split here and split here. Some will go to the left, some will go to the right. So let us name that what will go to the right as I2. And we realize that current, so when I1 gets here, split, some goes here, some goes here. But realize that at this node, let's apply KCL. Sum of currents entering a node is equal to sum of currents leaving. So to find the current that will be leaving this node here would be I1 minus I2. So after doing this, we've now analyzed our circuit. So all that is left for us is now to apply KVL and KCL. So I'll first of all apply KVL in this first loop, and I'll take my direction in an anti-clockwise direction. So applying KVL in our first loop, this left hand side loop, we get the voltage source. We are moving from a lower potential to a higher potential. That is why it's 12 volts, so it's positive 12 volts. Then we meet this resistor first, but the current that is flowing through this resistor is I1, so it becomes 6I1. Then we are moving here. The current that is flowing through this 4 ohm resistor is 4I1 minus I2. Then the current that will also flow through this resistor will be the same because the 4 and 8 are in series, so it will be the same current. That will be 4 minus is 4 minus 4 minus I2, so the same current. Simplifying it further, we end up getting our final answer as 12 here is equals to 8I1 minus 18I1 minus 12I2. Then we take another loop equation, so we can see that we can consider this second loop. So considering that second loop, so the middle loop, let's say the middle loop, then we also write a KVL equation. Let us also take the clockwise direction. So writing a KVL equation, realize that we are here to, we'll be moving from a lower potential to a higher potential. Then we meet I1, 6I1 plus 6I2 plus I2 will get here. When I2 gets here, it will not split because there's an open circuit here. It just flows, all I2 will flow through this 2 ohm resistor and come back to the voltage source. So it plus 6I2. Simplifying this further, we get 12 here is equals to 6I1 plus 8I2. Then we solve equation 1 and equation 2 simultaneously to get I1 as 1.11 amp and I2 as 0.667 amps. And after solving that, we now write a KVL equation for this. So we can just write in a KVL equation for this. We know that our voltage, our current was coming in this direction, I2. I2 flows through this. So since I2 flows through this, we can just write our KVL equation for that. So we can say our VTH is equals to 2I2. So in the last loop, So our VTH is equals to 2I2. That would be our voltmeter reading. So that wouldn't be VTH. So, but it's just VTH. That's what they are trying to. So we know the value of I2 already. We multiply it by that to get 1.33 volts. So the reading you will get when you connect a voltmeter here will be 1.33 volts. So I'll confirm this with a simulation. So going on for the B says find the total resistance between the terminals A and B when the source voltage is deactivated. So meaning we should find the total resistance that will be in the circuit when the source voltage, this source voltage is deactivated. So we deactivate it here. Then what do we realize? Realize that the 4 and 8 are in series, so we can just add them up. After adding them up, realize that the answer we get is in parallel with this. So so the answer we get 4 and 8, we get 6. So 6 and 6, we get 12. 4 and 8, we get 12. So 6 and 12 are in parallel, then we get 4. Then we realize that afterwards we can clean this and now replace this with what do we call it, 4. Then we realize that the 4 we get here and this 4, this 6 are in series, so we can just add them up. After adding them up, the whole thing, the 10 and the 2 will now be in parallel. So we just do that to get our 20 over 12 ohms. So it's telling us that if we would have connected an ohm meter here, the readings we'll get will be 20 over 12 ohms. So this is basically how we calculate this question here. So it's as simple as that. You calculate your VTH, you apply KCL and KVL and KCL to calculate your resistance here. Then you are good to go. So the next video I'll use a simulations to confirm these answers for us. Okay, so thank you very much for watching up to this side. This is our last video series on unit 1, and in the next video that I'll be covering, I'll start with unit 2, how to calculate the various waveforms, how to calculate RMS and average value for the various waveforms, and power in AC circuit. So please remember to like, share and subscribe. I also do a simulations to confirm these our answers we just found. So thank you very much and have a great day. Bye. I'm signing out.